Thank you, Matthew. Can anyone hear him now? I know you can hear me. Yay, okay. So hopefully the people online were able to see, in fact, that these are the questions that are asked. If you were confuzzled about that, please chop, do them real fast and don't listen to me real fast. So I'd like to start each day with a smidgen of this. Most of you are real good with most of this. But my strong suspicion is, why do 90% of the people say physics is hard 90% of the time? They're not talking about the physics, it's the math. Or why is the physics itself hard to learn? Because it's the math is getting in the way. The entire first month of class, you know, I taught you guys like one physics concept, the rest was all math. Well, that was math. There's no physics in kinematics, it's just applied math. For that matter, some people would say there's no physics in physics, there's just physics is applied math. So refreshing, strengthening your foundational skills, my hope is we'll make all this much more easily. Let's practice algebra. If I want to solve for, please note, very carefully, solve for u squared. My trick is to think of what order would I evaluate things in, and then undo them, peel back the ogre, the onion, in reverse order. All right, what is the first order in order of operations? Parentheses. Do you see any parentheses? What's the second order in order of operations? Okay, so the u squared binds, the v squared binds tightly. That'll be the last layer I undo. Actually, I won't undo it at all because I asked for u squared, but still. Yeah, read carefully. What's the next order in order of operations? No. Multiplication and division left to right, same order. It is not multiplication before division. Who's surprised by this? Or who thinks I'm lying? Oh, you remember dimly what this is? Okay, on Facebook, there are 50,000 nobody can solve this puzzles, and 50,000 people in the comments demonstrating that, yes, indeed, they have forgotten third grade math, where it is, fourth grade math, where the entirety of the puzzle is, do you multiply before you divide? Do you add before you subtract? Or do you do them left to right as they occur? You can look smart on all of those puzzles just by knowing what PEMDAS says. Parentheses first, then exponents, then multiplication and division simultaneously, left to right, then addition and subtraction simultaneously, left to right. Anyway, so the next is multiplication division. What have I got in here? I've got a layer of multiplication. I've got a layer of multiplication. I've got a layer of multiplication. And then finally, addition and subtraction. Yes, so anyway, now what order am I going to peel this onion back in? I'm going to skin the ogre by getting rid of the subtraction first. Well, hold on, let's see. Let's strategically think about this. I don't like negative numbers, and I don't like fractions. I would like to do things to both sides which simplify this expression and get rid of negatives and fractions. I want u squared alone by itself in a dark alley so I could beat it up and take its lunch money. Anyway. So if I want to get u squared alone, actually, I think a nice first step to do would be to multiply both sides by -1. Negative 1/2 v squared equals -2a plus 1/2 u squared. Second step is now I'm going to remove the 2a, which is attached to the outermost layer, with no fear of screwing up the half u squared. I would get rid of it by doing the inverse operation. If I've got -2a added to it, I'm going to subtract off -2a, which also goes by the name of adding 2a. If I subtract -2a, that becomes 2a minus 1/2 v squared equals 1/2 u squared. The second layer here of the onion is the multiplication. So I'm going to divide by 1/2. No, that way lies madness. What do I do instead of dividing by 1/2? Multiply both sides by 2. Okay, what's the final answer? Most people did tell me this correctly. Be careful. Getting rid of the 1/2 does not just get rid of this 1/2. Multiply both sides by 2 means that both the 2a and the negative 1/2 v squared get a 2. Well, a second 2 in the first case. Sha is good. Most of you got this. There was a problem number 8, I think, on the homework, asking about at what height do we reach half of the maximum speed of the ball rolling down one hill and up the other. I strongly suspect that we're that rectia, if that rectia is in the algebraic symbol manipulation, because I didn't give you numbers to plug in. I totally reserve the right to ask you for things without just pure numbers on them on the test. You will note, you could see by the proportion of the time that I spend asking for algebraic expressions on finals and midterms is low. You can expect that the final will be similar to the midterms. So I will only be asking for a few algebraic expressions. But, do this, practice this, learn this. Algebra 1 is for you too. Everyone. Quintuply so for people taking the DAT or MCAT. Okay, C and D. I was very pleased to see you got better than 3 o'clock class. Yay! But not perfect. Let's talk about this. The angle between right and up. This is 1/4 of a complete circle around. A complete circle around is 360 degrees. 1/4 of 360 is 90. This also goes by the name a right triangle, or a right angle. If two things are perpendicular, that's a right angle. 90 degrees was the correct answer for C. D, more people got confused. There is no difference between a horizontal line and a horizontal line. If I've got two horizontal lines, if I have two horizontal lines, I would just call that 0 degrees difference between the two, right? Vectors have a sense to them. Left and right are different directions. These two vectors do not have 0 degrees between them. That 0 degrees, 1, 2, 3, 4, 180 degrees difference between these. Left and right are as far apart as you're going to get from each other. Okay, so yeah, if I said the angle between leftward and rightward, would that be less ambiguous to you? Yeah, leftward and rightward. Okay, okay, yeah, there we go. So I would like everyone to know that opposite directions is a 180 degree angle. Now let's do a little work on a problem that involves work. Because here's something that Alex and I and the 3 o'clock class saw. Alex is the SI instructor. We see this as really probably the thing that is still sticking in your, not sticking in your heads, not sticking in the sense of you're stuck on it. It is sticking. Wait, how do you say that? The thing that you're having the hardest time with. Here we go. So here's a physical situation. Here's a wooded slope. A kid is pulling a sled up the slope. Let's say the sled is 40 kilos. And the kid exerts 30 newtons of force on it. And they move it 100 meters up the slope, which is at a 30-degree angle. And there's friction here. Kinetic friction coefficient is 0.1. and the kid has their little brother clinging to their back with a mass of 5 kilograms. And their initial speed, V initial, equals 3 meters per second. Find the work done by the kid on the sled. Find work done by kid on sled. In other words, by them on that. You have 10 seconds, which should be all it should take. Hint, hint. If you don't know how to calculate it fast enough, then tell me what you would type into your calculator. Time's up. 3 of you pass. Oh, all right then. Take another few. But I'll give you a big freaking hint. I may or may not have provided more information than is necessary. Yep. This is where you guys are dying, isn't it? This is the hill you will die on. Okay, so let's drill down. I have my strong suspicions what's killing you. First layer, can you state the equation? Question F, state the equation for work. What are you trying to plug into? Everyone, what is the equation for work? Okay, so most of you are able to state correctly the work formula. Work equals force, distance, cos of the angle. I let you skip over the cos theta if you know what it means. And in particular, what it means to have a cosine of 0, a cosine of 90, and a cosine of 180. I'm going to stop suggesting that for now, because I think that might be screwing up half of you. It'd be screwing up 10% of you, but I don't want to screw up anyone. Let's state it with the cos theta for the foreseeable future. And if and when I've got almost everyone getting this right, then I will let you elide it, to skip saying it. Okay, so now we're going to identify G is what is F, H is what is delta X, I is what is theta. So your first question, question F, was can you state this? Now the next three questions are what are these terms? What values are you plugging in? Because I'll tell you, only about 40% of you are getting this right. Okay, so Raymond, F is what is the formula? G, H, and I are the values of force, distance, and angle, please. Aaron, you too. G, what is the force? H, what is the distance? I, what is the angle? Quentin, don't just tell me the total equation, please. Tell me what value are you using for F? That is question G. What value are you using for distance? That is question H. What value are you using for angle? That is question I. Yes. One more time. Question F, state the equation for work. The correct answer is F, distance, cos theta. Question G, what's F? Question H, what's X? Question I, what's theta? So each of the parts of work, what are those values that you're plugging in? Let me be more specific because in I, half of you were telling me the cosine and half of you were telling me the angle. I, what is the angle that you are plugging in to cosine? Don't tell me cos theta. Just tell me what is theta. F, X, theta. Okay, great. I was right. I love being right. No, that's not true. I love being wrong when I'm being pessimistic. But I think I know where you're hurting. And it's the same place that I screwed up 50 years ago when I first learned physics. You correctly identified force. I told you the force, 30 newtons. We want to find most of you got this. If we want to find the work done by the kid on the box, use the force that the kid exerts on the box. There are lots of forces in this problem, by the way. We could find the weight of the box. We could find the force that the baby brother is exerting on the kid's back. We could find the weight of the kid that's pulling the box. We could find the normal force, the friction force, your mama's force. I don't know. You could find any force. But if I want the work done by the kid on the box, of the kid on the box, you got that. Step dose, what is the distance moved? And every single person correctly identified, except for the people who are not answering for some reason, every single person who answered correctly identified the distance is exactly what I said, 100 meters distance moved. Where you're almost all dying, well, where 60% of you are dying is the 0.3 on the slide that I introduced this with. Theta is the angle between distance and force. Theta is not just any old angle. Everyone, with your hand, get your hands out, get your hands ready. Point physically. Which direction is the force exerted? Point in the direction of the force. Everyone, give me a big, not just your hand, smack your classmate in the face with your arm. Show me with your arm. Let me see everyone. Up, up, and away. Uphill, yeah? That's the direction of F. What direction is X? The change of position. Like my kid when he wants, my baby when he wants something from me. Yeah? Okay. Anyone want to change your mind about I? Go ahead and put your new answer in for I if you've changed your mind. Think about what I defined theta as when I taught you F, force, distance, cos theta. One, two, three, four, five, seis, sieben, ocho, nueve, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 of you got it. 25 of you got it. 26 of you got it. 27, 28, 29, 30, 31. That's a third of the class. 32. Okay. That's better. Two-thirds of you still don't got this, so pay attention. Listen up. The meaning of theta in cos theta is the angle between the two vectors f and delta x. That's why I had you point your hands. What is the angle between two parallel vectors? It is not 30 degrees. This is 30 degrees. This is 0 degrees. So the correct answer for I is not 30, it's 0. When would the answer be 30 degrees? If I were exerting a force directly right, or I guess directly left. No, then it'd be 150. The angle theta is 0. Cos 0 is 1. But I specifically asked question I was, what is the angle? Okay, so turn to your neighbor and express to them, what does theta mean in force distance cos theta? In your own words, 2 seconds, real fast. Say it again. So we're pulling straight horizontal? I mean, I would say that the ground is along a level. I would say this is pulling along the ground. If I'm going up a slope, I don't know what sea level looks like. Okay. If I'm pulling strictly horizontally, then theta would be 30, yes. Cosine of negative equals cosine of. Cos negative x equals cos x, so it doesn't matter. Now, there are cases where that distinction of clockwise versus counterclockwise does matter, and none of it is important for 100 level physics. Okay, so before we move on, questions. I now have some exercises to help you practice this. Find the angle that you would plug in for everything, every force that applies to this. Suppose there's friction, there's work, there's weight, there's friction, there's normal force. find the angle that you would use. I don't want you to find the work. Again, do not find the work. If you tell me the work in joules, I will mock you publicly. Maybe not, but I'll want to. I will definitely look down on you. Tell me the angle. Tell me the angle for the weight force, the angle for the normal force, the angle for the friction force. Yeah? I think we're on FGH, aren't we? No, we're not, are we? What the hell? Oh, I had a bunch that I didn't say. Thank you. That's why you're my favorite. JK. L. So JKL, tell me numbers. Just give me the number. I want your number. No, I don't. I want the number. Yes. What do you mean? The angle between two vectors is. Oh, you mean positive versus negative? What number would you plug in to the formula force distance cost theta? That's what I'm looking for. We just discussed the meaning of theta. There is a correct answer for each of these. For this example, you're going up a hill, it's 30 degrees inclination. Find the direction of the weight, find the direction of the normal, find the direction of the friction, and then tell me, what angle would you plug in if I were evaluating work? You should work together, y'all. Work together, please. Oh my God, don't tell me cosine of. I'm looking for theta in angle. Gesundheit. Alrighty, almost time. Take your best shot, fire away. Okay, I'm gonna say that's time. Three people got J correct. Half of the class got K correct, half of the class got L correct. Yep, this is why you're struggling with work. But this is good. When I know where you're suffering, I can help with that. Here's how I would guide you through. First off, if you're one of the three who got J correct, great. Or the half of the class that got K and L correct, great. Bear with me for a minute. Here's how I would guide you through solving the rest of this. First is, can you correctly identify which direction the other forces are? Each of these forces are. Everyone, point for me. Which way, use your whole arm so I can look at the class and see. Which way does weight point? Right? Yeah? Okay. Now, carefully, relative to this diagram, which way does normal point? Yeah, that's screwing you up. Okay. How did I define normal once upon a time? Anyone remember? Perpendicular to what? To the surface. What is the surface? What is the surface here? The surface of the hill, the surface of the mountain, whatever this is this. Which direction should I point to be perpendicular to the surface? Is this perpendicular to the surface? Is this perpendicular to the surface? Which way is perpendicular to the surface? Normal is at right angles, 90-degree difference with respect to that diagonal line. Let's actually just draw the forces on this. Okay, so we had one force that goes that's the tension force. We already did him, check, whatever. Normal force at right angles to surface, not straight up. Weight force, y'all got that. And friction force, which way does friction go? Everyone point, show me visibly, let me see y'all. Okay, and that's what's screwing the other half of you up. Right. How did I define friction once upon a time? Does friction stick surfaces to each other? Does it make them cling to each other so you can't pull them apart? No. That's glue, not friction. If I rub my hands together, friction is not sucking them into each other, nor is it pushing them apart from each other. Friction is opposing in this case, the up-down motion, in this case, the left-right motion of my hands. Friction was defined once upon a time as a parallel to surface force. Friction does not point left. Friction does not point left. Friction points downhill. Forced step. Turn to your neighbors and argue about these. You must know these directions, or any hope of understanding work is hosed. But talk to your neighbor real fast. How do you know why is tension uphill? Why is normal diagonally offhill? Why is friction downhill? Why is weight straight down? If I'm on a slope, if I'm on a hill, here's my ground. Yeah. This is the surface. Normal, perpendicular, with respect to surface. This is the ground. Sure, here's an sea level constant altitude line. But if I'm on a mountain, the ground is tilted. The ground is really tilted. And think about it this way. If there's a force pushing me straight, directly, actually left, that's going to make me want to fly off into the air? Nah. Forces that are opposing my motion are going to point in the opposite direction of my motion, not just straight off into the air. Friction opposes the relative motion of the surfaces. The normal doesn't do what? Yes. Okay. Let's bring it together. If you've got this, wait, one more step for you guys to do, and then there is one new thing I want to teach you today, to make to give us more freedom to do things. I'm introducing one new piece of information today. Which direction is the displacement? Uphill. Okay. I have sketched in enough information now. Oh, let me copy this back down. Let me copy this. No, screw it. If I copy it, that's adding extra. That's possibly more confusing. Okay, I'm going to give you 2 minutes to change your answers for J, K, and L, if you wish. I'd like to see if anyone figures out their mistake, or for that matter, if anyone was guessing and gets it wrong the second pass. Real fast, talk about J, K, and L, see if you can figure out a better answer this time. Can you fix your mistakes? Good. More people are getting J. I would accept compliments as well. I mean, I always do. Good. People are clicking. Oh my God, don't tell me sine theta. Tell me the angle itself. Okay. And that's all the time we've got for that. The correct answers are 120, 90, 180. Let's find out why. Okay, so the first one, what did I ask? Weight. Which way is weight? Weight is straight down. Which way is displacement? Up and right. How can I compare these angles? Well, I know that the angle that upright makes with respect to straight right is 30. Right? That's what's specified there. So if this angle is 30, what's the angle between right and weight? That's a right angle, baby. What's 30 plus 90? Second one to analyze. I gave you weight. The second one was normal. Normal. Displacement. What's the angle between these two directions? I gave credit for 240 as well. However, cosine of 240 equals cosine of 120. It doesn't actually matter which one you use. Okay. Yeah. So what's the angle between these two? 90. Please note, if you don't got this right, put this on an equation sheet. Draw perpendicular lines and remind yourself this is 90 degrees. Draw anti-parallel line segments and point out this is 180 degrees. There's no shame in doing that. The only shame is continuing to be wrong after you've been led to the water and refused to drink. Okay, last one. What is the angle between the force vector and the displacement vector here? 180. Yeah. Again, why isn't it 0? Because these are opposite directions. These aren't lines. Lines don't have a sense. These are rays. Well, they're not rays. They're directed line segments. They have an orientation. And unlike many people, the orientation of a vector doesn't have to spend its entire 20s figuring itself out. It's just you look at it. It's as simple as that. I think that the lead up needs work. I'll work on that. Next semester it'll be funnier, I swear. Or I'll forget and tell you again next week. The point is 180 degrees angle between the friction and the displacement force. So I would plug in cos of 180 in that one. Okay. That's the time we've got for this. Before we go, don't go. There's new information. I was originally going to cut this out. I planned to cut this out. But then I wrote the quiz and the homework and stuff for last week and realized that there are too few kinds of problems. You're going to get stuck looking for patterns that don't exist because you've only got 2 puzzle pieces. The only forms of energy being gravitational potential and kinetic makes it harder, I think. So sorry, not sorry. I'm introducing a new formula for you, a new kind of energy. But I think this will make things easier. Actually, it'll help you see the connections and the patterns. It'll give you more opportunities. This is fair game for the final, for the quiz, for the homework, for the everything. I'm incorporating this material just because I didn't originally plan to. This is part of the course now. Elastic potential energy. Oh, also another thing that tipped the scales for me is MCAT asks about springs and elastic potential energies a fair amount. So not everything that's on MCAT is in here. Not everything that's in here that is on MCAT, but I like to align them when I can. Here's another argument for doing this. Okay, elastic, or also called spring potential energy, is the energy that is stored in the deformation of a medium, the deformation of an object. When you think of spring, don't just think of a coil of wire. Yes, a coil of wire can be a spring. It could be small like a pen spring. It could be big like a car shock. But a spring can actually be anything that tries to return to its equilibrium position. If I sit, God willing, this will be very embarrassing. I have been trying to watch my weight a little bit, but okay, the table didn't break, thank goodness. If I sit on this, this might look like it's just, the table is just sitting there, but I promise you it is actually bending at the eensy squeensy teensy bit. You could see this more if I stand here on the very edge of the table and jump up and down, and I just realized my wife would kill me if that did. Maybe I won't do that. But you can imagine, right? If you jump up and down on this, you apply a big force, this does actually bend a little bit. Tables are springs. You know what else is a spring that the doctors care about? Bones are springs. If you apply enough force to a bone, pulling or twisting or turning, well, if you apply enough force, you can break the bone. But if you apply less force than is required to break the bone, you can get a bone to bend a smidge. And actually, the amount of benditude, the amount of strength in the bone tissue is crucial for understanding. I've been told, I am a doctor, but not that kind, assessing bone health. So osteoporosis, there will be different qualities, different measurable quantities of what we're about to discover is called the Springs constant, also Young's modulus. Okay, so that's the lead-in for what is a spring, what do you have elastic potential energy? Anything that tries to return to its equilibrium position is a spring. Before I can give you the formula for UE, I need to tell you the meaning of the constant that appears in it. Spring constant, aka stiffness of the spring, is given by the formula K is the ratio of how hard you have to push to how much change in length you get. I mean, that should actually kind of like make some kind of sense. How stiff is the spring? Well, a stiffer spring, you have to push harder to get it to change, right? The ratio of how hard you have to how much you get, that's K. That's the meaning of the spring constant. And the big dealio is for a large range of springs, for a large range of delta x's, this constant is constant. If it takes 2 newtons to compress something by 10 centimeters, it'll take 20 newtons to compress that same thing by, it'll take 4 newtons to compress it by 20 centimeters. And it would take negative 6 newtons of pulling to expand it to negative 30 centimeters, to expand it 30 centimeters instead of compressing that same amount. Does that make sense? It is a linear relationship, a proportional relationship. If you divide any force by any change in length, that should be the same thing for a given spring. Obviously, my bone, my arm, bends a much smaller x than a pen spring would bend for the same force. So spring constant does not mean all things have the same constant, but for a given object, there's a direct ratio between these two. You can find out how much force the spring exerts by doing K times its stretch or compression. You can find the length of it by saying F over K, whatever, or rearrange it however you like. K is a constant for any given spring, any given material. Let's do an example. Yeah, question. It does need more force. The bigger the stretch or compression, the more I stretch it, the bigger delta x gets. If K is a constant, what happens when x increases and K doesn't? Do an example. Let's do an example. 100 grams dangles from a given spring and it stretches by 5 centimeters. Find K. Again, I'm going to dangle 100 grams of brass from a spring and it stretches 5 centimeters. Give me the spring constant. Oh, what are the units of spring constant? Gotta be. What have they gotta be? What is K measured in? Newtons per. F is newtons. X is meters. Newtons divided by meters. Newtons per meter. Newton meters or Newton joules would be force times distance. This is force divided by distance. Okay, so again, one more time. Dangle. What question are we on now? Mm. Mm-mm-mm. Make sure to do your unit conversions correctly. Good job, Brianna. And Venice. And Josh. Not Newton meters. Not Newton meters, Helen. Newtons per meter. Newtons divided by meters. Okay. We got to let's put this puzzle piece together. What force is applied when I dangle 100 grams? It's not 100 and it's not 0.1. Weight. What is the weight of 100 grams mass? 1 Newton. 0.98 if you're being picky. Yeah, weight equals mg. M in this case is 0.1 kilos. G is, as always, being rounded to 10 because I am doing stuff in my head. Okay, so I would say force for this would be 1.0-ish. What is the delta x? 0.05, good. 5 centimeters of change in length. 1 divided by 1/20th goes by the name of 20 newtons per meter. 19.6 if you're using a calculator. Although for that matter, I gave you one sig fig here. The 20 actually is the scientifically correct answer. Okay, anyway. Follow-up question to make springs make more sense and is how far would it stretch if you dangled 400 grams from? Again, follow-up question. N is what sort of stretch would you get out if you dangled 400 grams instead of 100 grams? What exactly? So many of you got the last one right. Good, good. Springs aren't that bad. Whoa, hold on, cowboys. I've gotten a number of people telling me newtons per meter. What do I measure a delta X in? What does delta X even mean? What is the new change in length? How do we measure length? Meters. Centimeters if you want. I give credit for that. I would default to meters, but still. Okay, so you could do this in a couple of ways. One is I've got K. This K applies for any force applied to the end of the spring. So I could say 20 is the ratio of force to delta X. Well, I now know a force. What's 0.4 times 9.8? It's 4. 4 divided by what is 20? 1/5? Duh. Now, here's another way you can do that. And you could say, if this constant is the same for all things, I could set up any ratio. F to X is F to X. The ratio of force to stretch is the ratio of force to the stretch is the ratio of force to the stretch. So if I apply 4 times the force, I get 4 times the stretch. Bing, bang, boom, done. 4 times the force, 400 grams instead of 100 grams is going to 4 times the weight force. Instead of 5 centimeters, I get 4 times 5 centimeters. Great. Do you feel okay with K? Now let's do the problem itself. Now let me introduce the equation itself. The potential energy stored in a spring can be calculated using the formula: half times the spring constant that I just introduced times how much the spring is stretched or compressed squared. You might also see this with an S, sometimes KS squared. Yep. You will also, in your textbook, you will see a minus sign in the expression force was negative K delta X. All that minus tells us is that if I apply a force, if the spring is trying to expand, that's because you've compressed it. The change in length is negative, means the force is positive. If the change in length is positive, the force will be back negative. Oh, someone had a question up. Yeah, mass is 0.4 kilograms. Christian, yeah, okay. So mass is 0.4 kilograms, but the formula for force, mass times g, would be 4 newtons. So the formula is not mass over change in length, it's force over change in length. And based on how I was using this as a brass weight hanging from it, to find the force, I would use mg. Okay. Let's apply this here. Find the elastic potential energy stored in the spring in the second case. I dangle 400 grams. It stretches 20 centimeters. How many joules are stored in this spring system? Okay, and then I'm going to do follow-ups. Suppose I use this much energy to shoot the 400-gram slug sideways. So if I captured all this spring energy and used this spring energy to power a spring gun, how fast could I get that going? Or the next question would be, if I use this energy to lift something, how high could it go? How high could the 400-gram slug go? Does that make sense? So question O, UE equals, P is V max equals, and Q is H max equals. In other words, if I transform spring potential into kinetic, or if I transform spring potential into potential, what would you do? K was, what did we just work out, K? K is 20? Mass is 0.4 kilos. And the stretch or compression was 20 centimeters, 0.2 meters. Atham, you're done. You can go. Good job. You finished it. You got it right. Or Atham. My apologies. Devin, you too. You're out of here. Good job. Is this motivating or is this embarrassing for me to let people go find the maximum height if I transformed all this spring energy into, shooting the 400-gram slug vertically? How much height could I get? So many correct answers. I'm not even going to be able to read them all out. The neat thing about point Q, but it is late. I'll tell you later. We'll start with the extension next time. I'm gonna say, okay, if you got 0.4, 1.4, and 0.1, get out of here. You're done. If you are stuck anywhere, confuzzled, or even just confused, stick around. Or even wish to. For the three of you that applies to. Yes. Yes. Because of K, M, and delta X, just the way the numbers worked out. Yeah, they won't in general be. and stopped recording. I remembered to stop.